What is
I
this?
see some too. 105, right? Your fingers.
You can see right there. You can have it like that. Nice. Anyway, your thumb is big enough. You know?
Okay.
You see, all right. Okay, I honestly, I doubt you probably see this configuration in your lifetime. It's more or less a theoretical configuration right now because I've never seen it anyway. So these are here for when your load is varying from hot pull down to hold in. All right. In holding, I only need one of these risers. During hot pull down, both of them is in operation. Okay, because you have more refrigerant flowing through that.
Yeah.
That thing. Well, of course, with this, the reason they put this is to ensure like 100% oil return. Because once the oil hits here, it is going to return here. But if I have one common suction coming up straight here, what I have to do is, say this may be 7/8 inch, this may be 7/8, I'd have to up this to 1 inch. But here's the thing, as I increase the size of the pipe, what's going to happen to my velocity?
It's going to decrease.
It's going to slow down. But if it slows down, it's going to trap oil out here.
On the side.
Right? So that's why they use these to go back directly into.
And once it hits the downward slope, it's
Yes, and you know, you keep it down, you get all the oil return to it. And it's very critical when you have multiple evaporators.
Those are pump down solenoids? Or?
Yeah, these pump down solenoids for each of these evaporators here. And one of the reasons they have this set up here. Imagine this is in this room here, both of them. But that section, you know, essentially one unit will not cool this room now because you're not going to get airflow covering the whole 360. And once we use two of these, you're practically creating two temperature zones. So we're going to have two separate thermostats, one on this, one there. So when this section is cooled down enough, it cycles off this one and allow that to run. All right? Hence, the need for two separate lines. All right? And it's interesting if you go into a refrigerated warehouse where they have loading docks. This is how they have it. They have a long line of evaporator units. And all may come off of the same compressor bank or single compressor. Each of them will have their own thermostatically controlled thing. The thermostat is right behind it. So that each zone, because each one of the loading dock door will have one of these placed right in front to keep that section cool while the truck is off-loading and while they're loading again.
And it'll just shut off when
when they close on the door, it shuts off that section when the temperature here is being satisfied. And eventually, hopefully, you get uniform temperature throughout the dock. One of the things with this, guys, is kind of difficult sometimes to troubleshoot this. these systems and find out exactly what is wrong. Because if this system is low on refrigerant, it's not the easiest thing to determine, because there is no way that all of these will be calling for cooling at the same time. And the only way you can know if the system is low on refrigerant is when everything here is calling for cooling. That means you're loading the system to maximum. Therefore, you will be able to charge up to suit worst case scenario, which is every one of them on. So that's one of the difficulties with this. And the thing with certain warehouses, it may be milk. So if you lower the thermostat on each one of them, you may freeze the milk by the time you finish the service call. So, you know, I work on some of these milk distributor warehouses, and that's one of the biggest challenges. Not to freeze the product while you're doing the service call.
How much of a pitch you gotta go down on that?
I think
You wanna do the pipe?
I would go quarter inch per foot, which is about 4 inches per 10 feet.
4 inches per foot?
No, quarter inch per foot,
Quarter inch.
which is 4 inches, 4 inches per 10 feet. If the only time you see me do a 4 inch per foot is probably if it's a freezer drain line, to drain water as fast as possible outside of that freezer so it doesn't freeze up when the unit kicks back on. But other than that, quarter inch and a half, which is pretty much standard plumbing rules. Follow that and you get it. See, the slope is just to assist, it's not to take over the function of this. Because ultimately it's a compressor suction pressure that would pull that oil back. Not the slope. Of course, the slope we have drained it in the off cycle. So, see what I was just telling you guys? You have a big line here. Going up, it's going to be pretty tough to get all your oil up. So 2 little lines, higher velocity. Once you reduce the line size, you get higher velocity. Higher velocity will pull more of that oil up without no problem.
What's that?
All right.
Repeat that again? Once you what?
Smaller lines
Uh-huh.
increase velocity.
Okay.
Once you have increased velocity, the oil will have no problem getting sucked up, going up into back into the compressor. And it doesn't really matter here that it goes into a bigger line because it's already pretty close to that, the compressor takes.
And it's sloping down.
Yeah, and it is sloping slightly downward. So one of the things we do not do in refrigeration, on the liquid line, we never increase as we go towards the evaporator. It's okay that you decrease the size, but never increase the size as you go towards the evaporator. With the suction line, you can increase the size of the line, but you're going to end up getting lower than normal pressure in that line. And that would throw off when you think, you'd be there thinking that, hey, you know, I should be reading 25 psig here, but I'm reading 20. So I need to add more gas to bring this thing up by 5 psig. But you're already at full charge, and the only reason it's reading that 20 is because you increase the size of the line.
So you decrease the size of the line.
So you have to, no, in this case, maintain the same size throughout. And if you're going to decrease, you do it only because you're losing velocity. You're not doing it because you want to do it. Because you're going to screw your whole system.
Everything already comes set up, right?
No, you have to set up your line. Walk-in boxes.
Nah, but I mean, everything already comes set up concerning, like, all right, this amount of feet for this line, this amount of feet for this line.
No. You have
Yeah, that
to
was just up.
determine that. When you're setting up a walk-in box, this is the size your customer will want, right? You're going to order that box. Now you're going to determine what size of condenser unit you need, what size of evaporator unit you need. You're going to determine, well, of course the evaporator hangs in the box. Now you're going to determine where do I locate my condensing unit. On the roof, right outside, on top of the box, to the side of the box. Now if I'm going up to the roof, if it's a roof like this, which is 30 feet up, now you got to figure, I need a P-trap down in the box, and I need at least 2 more in between when I get up. Then I need a reverse P-trap up on the roof. So I'm looking at 4 traps.
Add that in.
Alright? Then I need to trap the discharge line. Alright? And then I need to determine whether I want to decrease that line size or increase, but typically we do not.
Leave it the way it is.
We leave it whatever. If the evaporator unit says it comes out to 3/4 inch line,
You want to stay with it.
stay with that, because most likely the line on the matching condenser, if you match it right, will be the same diameter.
Should be.
Alright? Now, what we do find sometimes is that this may come up with 3/4, actually 7/8, and that may be 3/4. It is okay in that instance to reduce right here at the exit of the evaporator coil. Reduce it down to 3/4. That's only 1/8 of an inch. But this is where I'm going to reduce it, right here.
Why?
Not down here or anywhere in between. There.
Why?
So I'll have constant pressure in here,
Yeah, it's
which I'll be
great,
reading.
right?
And I'll have the same pressure throughout this whole pipe.
Converted, yeah.
You
Alright.
won't lose any velocity or anything.
I'm not going to lose velocity. I'm not going to have any significant pressure drop that can affect my system performance. Right? And one of the beauty with these, they have a pressure tap valve right inside here. Now you can actually read this pressure to make sure you have the right evaporator saturation temperature. So these are the little things with refrigeration that if you don't address at the beginning, it comes back to haunt you big time. Right? And you know, there are some customers out there, they can, oh man, they can harass you. And they seem to take pleasure in doing it. Yeah, they wake up midnight and tell you their box ain't working. Can you come now? No.
McDonald's.
Midnight, that's 12
Yeah, even in McDonald's, sometimes they,
Myself,
you know,
right.
they understand here it's midnight.
Uh-huh.
True Gary, yeah. Price is right, I'm on it. I'll be there.
So this is how this will work. During times of low load, that works. And you will know because this is smaller and this is blocked up, so. But like I said, this you don't have to concern yourself with doing this configuration. Because it's kind of a very, very, very worst case scenario. Because if you got to do this on the up front, you really didn't do your math animal work right.
That would just be like poorly designed system, right?
Yes. So if you design right, you use. See, the whole idea in design is to use the least amount of material and get the maximum effect.
And use your money.
All right.
Make
And
the
get
most money.
get the maximum bang for your buck. You know. Yeah, I ain't even gonna go into this here double risers because like I said, if you follow that one rule, just go with the size of tubing that comes out to the units. Follow that, and most likely if you're buying a complete system from a wholesaler,
Can match it.
they'll match it because like I told you guys yesterday, I will give these guys the size of the box I need, all the dimension with the drawing, and tell them here, I want this box and I want to maintain it at a certain temperature and this is my load, temperature range, load, and this is how often they'll be opening the door or closing it and whether it's going to be used for hot pull down or holding.
Storage.
So all of that information I will give them and tell them, this is you size the unit.
So
for this
It's a
box, right?
mistake, it's their
And-
mistake.
Yes, and let them do it that way, because if you size it and you're off by a few BTUs, you're gonna run into problem, then you have to take that money out of your pocket and
That
buy the
hurts.
whole new system.
That hurts.
How would you describe the load to him? You say, you know, you want a whatever 10x10 box.
You gotta tell them what kind of food is going in.
Yeah, no, but I'm saying, yeah.
Shoulders are gonna be in
Yeah,
there.
right, you know, frozen food, but like, you know, you're gonna say you're gonna keep it at max capacity the whole time?
Well, if you order 10x10 box,
Right.
and when you say maximum capacity, you mean if
Right,
you're
you want
gonna
a
keep
full
it,
stock the whole time?
you want at least 50% of stock in that room at all times.
Okay.
All right, and here's the reason. If you have a box that 8 by 8 by 8,
Mhm.
and you only keep it at 25% full load,
Right.
then your compressor, your condensing unit will be short cycling because
Turn off and on.
Right.
by the time it starts up, it pulls down that temperature because there's no load. So that's going to short cycle. You're going to get moisture problem because if it's a box where you don't want very high humidity, you will end up with high humidity because you're dropping the temperature without removing any humidity.
Pulling the temperature
So
down to.
what you're going to have is sweat in wall, sweat in floor, sweat all over your product. And if it's something that you really don't need to have sweating or any water around it, like boxes with food,
Yeah.
you know, they're going to get soft. Then
But that's the people's fault. They told
Yeah.
you that they told you they got the wrong size. They said
Yeah,
that
but
they.
here's the thing. There are a couple of times when I install system, customers call you when they open their restaurant, and you hear my box is soaking wet, everything is wet. And you go in there and they have all the shelves around. You know, all the shelves look nice and shiny.
But they're
They have
empty.
pots and pans in there, but no freaking food.
Yeah.
So there's no load on the box.
Yeah.
So you tell it, guys, it is gonna be like this until you buy the product and put it in this box. It wasn't designed to run empty.
Mhm.
I mean, if you wanted something to cool pots and pans, you know, just put it outside and
Yeah.
hang it somewhere. You know, it's like-
You don't have the shit that's supposed to be supplying.
Yeah, you see when you size the boxes with the premise that these people are gonna keep it at least 50% loaded. Other than that, it's not gonna perform the way for what it was designed to do. No way. No way, shape, or form. So don't feel bad,
Can't do it.
it's never that's not your fault.
Right, you explain that to them, right? You said
Yes.
this is on the premise that you're gonna keep this thing half full.
Yeah,
At least.
and at least you're an optimist, you said half full and not half empty.
Yeah.
So that's the only way, and you know, if you find that's happening, normally a walk-in box will be at maybe they want it at 35 degrees, depends on what the product is. If it's bulk dairy stuff, you look at about 34 degrees, because you want to keep dairy pretty cool.
They're not frozen.
And at 34 degrees, it's pretty easy, you know, at the snap of a finger, you will get a ton load of moisture forming on your system if you do not keep the load. In a case like that, if you find that's happening, raise the set point temperature in the box. Instead of 34 degrees, go up to 38. Your dairy would not spoil, but you're going to eliminate that
Sweating.
sweating because now your compressor has a longer run.
That's gonna run, because you're gonna pull it from 38. You're gonna
Yeah.
wait till 38.
So what's going to happen? It's going to run, and it's not going to cool down that box to bring the dew point way down. So you're increasing your dew point, and chances are, hopefully, guys, it works. But the whole bottom line is load, because I always ask the customer, you know, what do you plan to store in here other than the usual things out of the way? No, we just, you know, vegetables.
Bean.
We're gonna take out, when the meat is like meat you put to marinate overnight, it's not gonna be frozen stuff. Let's say it's a regular 35 degree walk-in. And you find out exactly what it is, and you get an average idea what the load will be, and you work on the box. And more often than not, 99% of the time it works out. Simple, easy. But if you want to get really into it, you know, every substance has a specific heat.
Yeah.
So you will ask them, okay, how many pounds of vegetables, lettuce you see yourself having in here? 20 pounds. Lettuce has a specific heat, X, Y, Z. Then how many pounds of cabbages, how many pounds of carrot? You go point to point, how many pounds of these, and you find a specific heat, and you multiply that by the pound, and you get a BTU load requirements for that, and you add it up plus infiltration plus whatever, how many times you open the door.
Yeah.
You know, you have to find out if this will be like a hole-in box or a service box. If it's a service box, they'll be opening that door 10 times every 1 minute,
Yeah.
you know?
So storage box is kind of easy.
Storage box
because
is just,
long-term
they just take out
storage.
what they need, put it to a next location, close that door and forget about it until they need not a bulk set of
Yeah.
food. So all of those things you have to
What
take
about
into
the one
I've
consideration.
worked at
that
places
like,
where like, you know, like the storage boxes, you know, like they get dirty and then like, or they got sorted out and the guys just keep the door open. Like in the bomb, they just keep the door open.
Yeah.
Work on it like that. That affects it a lot, right?
Yeah, because you're gonna be pulling in warm, moist air, and you know, your system is designed to handle that,
I should use the hot breakdown too.
but it's not designed to work under that kind of condition, that kind of load. And one of the things is, we're not really, our system will handle it. Who wouldn't, the person who would be pissed at that is the health department. If the health department walk in there at that precise moment in time, they'll probably tell you to throw all the food out.
yeah, you
I don't know.
can. What about the
I don't know
freezers?
what-
The boxes that are long, they start out medium temperature for dairy and stuff like that, and then there's a door at the back of them.
Yeah,
Open
and
up
you have a
there's
freezer.
freezer in the back.
Yeah.
Yeah.
That's
That's just like a double box.
Yeah, that's
I mean, I can understand how the
That's like,
evaporators.
that's like Restaurant Depot.
Yeah.
You walk inside
Yeah,
the
but-
refrigerator, and then in the middle, they have a freezer.
Yeah,
Well, this one I'm talking about is the same thing, it's just long ways.
Yeah, you see it in a lot of restaurants where when you go in this first door,
Yeah.
this is a regular cooler, and you walk in, and the next door you
Same
open.
thing.
It has they share a common wall.
Yeah, they should.
You open this door and you go into the freezer.
Right.
All right, that's a double box, and more. In 100% of the cases, they have their own condensing unit.
Yeah, I
and
can
blowers
see
and
how
everything.
that would work,
And
but they do share that common wall.
yeah, and if they share a common wall, the load on both boxes are reduced.
Yeah.
And one of the thinking behind designing a system like that is if if the regular walk-in goes down, they can crack open the freezer door and keep the temperature here going. If the freezer goes down, you can open that door and keep the freezer at 40 degrees range. It will not spoil.
It won't still
So you're not
above
going to go
40
into the
degrees.
spoiling range. So it works out real good.
Because I saw that in a store,
Yeah,
in a fast food.
a lot of restaurants have that design.
Yeah.
But then it wouldn't be designed for that load though, right? If the freezer goes down and the refrigerator parts, the medium temp's trying to pick up that load from the freezer, it would be like an undersized system, yeah?
Well, here's the thing, the freezer can stay, the door can stay closed
Right?
until hopefully you get a service tech.
All right, I got
Typically, if you do not open the door to a freezer that was held at -10, that product can stay there for 48 hours before the temperature begins to change.
Okay.
As long as
And
nobody
you
opens the
keep it
door.
at a
Yeah.
deep frost.
So long as you don't open it like you normally will do. And that would give you enough time to get a service tech in there and do it, you know? And if you can, if the service tech comes in and then it's a condenser unit, but it's a special order condenser unit, you need it 4 days, then you can open the other door and allow that thing to
Right.
sit. And it will hold it, because remember that the freezer food was at a certain temperature internally.
Gotcha.
And
Yeah.
the temperature difference between the freezer and the walk-in box is very small. So there's not going to be a rapid heat transfer. If the differential is this much, the heat transfer is very rapid, right? And as the differential comes closer and closer, heat transfer is reduced. So it holds the food. And I've worked on a system where I couldn't get everything set up for at least 1 week. But it holds the freezer food over for that week.
Yeah, while you were ordering what you needed.
Yeah, what you needed, because like I said, there are certain things like the beacon system, which guys, after the next break, I'm going to show you everything how it works. Those, a stupid thing like a pressure transducer can take you 10 days to 14 days to get here. All right. If I order the board, I have to build the board. If I order the valve, it has the electric expansion valve. This is not a stock item for the simple reason it's too damn expensive. They have to build it.
They make it when you order it?
Yes, they make it when I order it.
For the beacon system?
Yeah,
For all?
or for all of them.
Oh, wow.
It's electric expansion valve. I mean, when you come to think of it, that thing is all told, shipping, handling, taxes, the whole 9 yards. I may end up paying $700 a
Yeah,
day.
you said
Wow.
that. You mentioned
All right, and nobody's going to manufacture something that costs that much money and put it on a shelf.
it. No,
You know?
wait for people to qualify.
You do. Most companies now do what they call JIT, just-in-time manufacturing.
Yeah.
So you manufacture when you need it. And they don't really care
About how long you have to wait?
You have to wait on me.
You need it.
They'll do it, they'll compete with the other people's selling the same thing.
Yeah, but you see, these guys developed this technology. They're the leaders in it.
Who's that, Sporlin?
Sportland.
So they run it.
They're the leaders in it, and they have their hand on the balls of the market.
Yeah.
You know? And the thing is, they can afford to be that way because not only do they have the corner of the market, but they're damn good. They're the best in the industry.
And all the stuff being made is
Most of your stuff is all Sporlin. You see,
Yes.
It's all Sporlin.
so.
Sportland, Emerson,
Yeah.
they're the same
everything,
thing.
yeah.
Parker, Hannifin, well, all of them is the same company now because each buying out each other to a point where this whole industry one day will be owned by one person.
Yeah.
Improper drain piping, guys, we're going through drain practices, right? 35-degree box, we can trap outdoor or we can trap it right here if we don't have if we have the space.
Okay.
All right.
And then-
There always should be a slope. Freezers, we always trap on the outside because you trap it here, the water that remains will be frozen in
And
there.
it's showing
The
the
line
heat
is
tape
representing
on
heat
it.
coil?
That's the heat tape.
That's a heat tape there, the black thing.
Right, that, right
The heat
But
tape
no matter how much of heat we put on this, it's gonna freeze.
on the
If it's
on the
inside-
beach trap.
if it's inside it, yes.
Oh, this is not accurate.
there. Oh,
Sense.
Right?
you don't need it or no? Tell you
Yeah,
that.
this we don't put in here for a freezer. It's out here. This one, we can put it here or we can locate it here.
Because it's not freezing.
Because this is not at freezing temperature.
45 degrees.
That one is. And this more or less drains constantly.
Yeah.
All right? This only drains when we go into defrost. All right? So it's not constant water flowing. And you see, apart from this heater that's wrapped around this pipe, a lot of times this looks kind of clear. You see that black thing in there?
Yeah.
That's an internal pipe heater.
You said you mentioned that.
So we also push a heater in there and hook it up in parallel with this heater. So you have two forms of protection in there. We get,
You say internal pipe heater? Or-
yes, you put the
Oh,
heater element in the pipe. Okay, it looks like a brazen rod with two wires come out that you hook up the line and neutral. And it's a second, you know, two heaters are better than one because
Would you insulate that after you put the heat tape on?
Oh yeah, insulate the hell out of it.
Okay.
Out of both of them or just the freezer one?
No,
The
next
freezer.
next one's gonna be inside.
You see,
Next one be inside, next one be outside.
That won't freeze.
sometimes with this here, if I have a situation where it's high humidity and this is sweating, I will insulate it. Simple reason, the health department comes in and sees sweat on that, they're gonna tell you to do it because they're gonna say, that sweat will drop on the food
Food, yeah.
and it's gonna cause cross-contamination. So, insulate it, it's better. This one, certain companies require that you put a 1-inch thick insulation around this. Alright? And guys, the thing is, you're trying to prevent this pipe from cracking, from freezing up and cracking.
It'll
Because
crack.
it's pretty hard. When these pipes are set like this, they're pretty rigid in position there. And it's pretty hard to unwrap this tape, change that little piece, and then rewrap that tape. At 10 feet length of pipe will require a heat and tape about 50 feet long to be wrapped around there decently to maintain the right temperature that day. And you know what it is to take a 10 feet length and just go wrap 50 feet of tape? See if that's half inch wide
5 times the amount.
around it. It's not,
That's not good.
you're gonna go lunatic crazy by the time you finish. And you see this air gap? Health department required it at one time. The first time it was 1 inch
No,
between
6
here and here. There must be a space of 1 inch.
Now,
Now they say 6 inches. Then they went back to the 1 inch. So guys, I put it at the 1 inch. Let them tell me I can always cut, right? It's easier to cut it off than to add a piece on. Yes. Kind of measure twice and cut once. Yes, sir.
or cut twice.
Cut twice, measure once?
Yeah. Well, if you leave it at 1 inch and they tell you 6 inches, then you
Yeah,
cut
the last
twice.
time you did that, you cut it 3 times and it was still too short. It was still too short.
I don't remember
Yeah.
that.
And then if you cut it the 4th time, it's still gonna be short.
That's what happens, yeah.
You know?
The 5th time is the charm. That's when you get it right on.
Good for you. Slow passage before, you will determine whatever. See the 4 inch, Mr. Yeah, the 4 inch per foot here for this one.
Deeper slope.
So in this case, you see P-trap can be inside or outside of the box, it doesn't matter. Sometimes if I have no space here because this may be in a place where they push stuff in the corner of a wall, you know, they like to stick boxes and what have you, or the cart, and if you know that, you know, they can put something and break this, I would just put this direct into here and put one of those S-trap I showed you yesterday,
The run in.
and I put that here and make this a kind of a little bit more heavy.
Okay.
Alright? And this size of pipe here, I do not go smaller than 3/4 inch. Never smaller. Because for some reason, I always find 5/8 inch and 1/2 inch blocks up for no
All the ones that I ever
logical reason at all.
3/4.
Biology.
And 3/4 inches, it drains perfect. So 3/4 now.
Is it kind of the standard too, right?
Yeah, it's industry standard.
Pretty much, the ones in the beverage are all 3/4.
Yeah, because everyone I've seen is 3/4.
Did we remember earlier I was telling you about ice formation and frost formation? There is a difference as to what causes it. See, and even coating of frost, yeah, that's normal on my systems, right? But if I have staggered areas of frosting, for example, on on multiple circuit coils, you may have one coil showing you an even line of frosting, the other coil may be frosted halfway in, and all the rest shows you even. You know what that means, right?
Like, oh, if it's
Yeah,
even except for one part of it?
Yes.
Yeah, that means that that one part is not cold enough.
That's the layman experience, the layman explanation. I want the service technician explanation.
So it's that
You have a
one
flash
part,
gas?
that one part.
You want the explanation for what? For excessive frost?
No.
If I have a distributor,
Uneven.
It's not boiling and that's
Uneven
that's
frost
washing.
on the freezer.
let's say this is a distributor here, right?
For the evaporator.
And I have one circuit there, another here, another here, and another here. This is frosted up right through, evenly, right?
Yes.
This one has frost only up to here. This is okay. This is okay.
That would tell me there's a restriction in that part of the distributor because
Right
it's causing a
there.
flash gas.
Yeah.
Yeah, right around here,
The restriction right there.
somewhere in here, there's a restriction.
And the other two are frosted though.
Yeah, this two
But
are frosted up
evenly.
evenly, right?
They're all even, they're all normal, they all shit freezer.
So the gas isn't
Right.
going into that part
Right.
of it.
No
And
temperature,
if-
they all shit freezer, that's normal application.
If it's like this, just the whole thing is uniformly only frosted like around this general area. Right up to
Okay,
there.
that would tell you there's a restriction in the whole metering device, right?
No, it's,
No, just
it's
that it's
even.
close.
If it's even,
Okay.
it's even.
I'm saying, if you're saying if it's just, all of them are just frosting up
Right up to this point,
up to that point.
yeah.
Either you're low on gas or
You're low.
something, or you've got a restriction in your metering
Yeah,
device.
that's the way we're looking for, the everything that could be possible here.
If it's too low, then
Could that
it's
be
not
a-
filling, it's not filling all the
Yeah,
way.
if it's slow and gas,
It wouldn't have enough. It would boil off
you
right
will
away.
typically see this, if not a capillary tube system, what you will see is the capillary tube itself begin to frost up right at the entrance. So once that is frosting up, it's an indication that you either have the restriction there or low on gas. And if it's low on gas, you will know because you have a correspondingly lower head pressure. But if it's a restriction, you have a slightly higher than
Higher
normal
head pressure.
head pressure
Yeah,
because
higher.
Backing
liquid
up.
refrigerant is backing up in the condenser coil. Alright?
Yeah.
So those are the little things, guys, you just
That's
look
what
at.
we
And
did
you know what? A lot of times, a visual check, and you see that, you just go check, stick on your gauges and shoot some gas in that,
Temperatures and
and you're in space. But now here's the kicker. If I had to put gas in this system, it means what?
There's a leak.
It means there's a leak. So I just fixed the symptom. Now I have to
Yeah,
fix the
find
problem,
the problem.
right? Putting in gas is just fixing the symptom, not the problem, or the cause of the problem. So
That's if it was
And
running
there's
fine.
also a fine for putting gas into a system that you know has a leak, right?
well, there's a percentage you are allowed,
Mm,
Right.
you know.
You're allowed to let it.
There's a
be.
percentage
Yeah,
you're-
well, if
Actually,
if
no,
you're
that-
constantly putting gas into a system
Yeah,
that
be-
you know has a leak,
Yes, constantly. If it's the first time,
right?
hey, I'm gonna do it then leak test, or I can leak test. And if there's enough pressure in there, hey, it may show up. If it shows up, then I go in there. If it's a pump down system, I pump down the gas, and depends where the leak is.
Some systems are allowed to leak indefinitely.
It's a 5 pounds or less.
5 pounds or less,
Yeah,
yeah.
they're
You know,
just allowed to
Um,
leak.
That's what they say.
It's
Yeah,
an EPA,
but you know
that
what?
doesn't
EPA.
require.
50 pounds
Yeah,
and up
that's-
is, you got 30 days, right?
If you really
Yeah.
check on all these rules and regulations, you need somebody who's specialized in just trying to understand.
Yeah.
I know.
And me, I don't bother. It has a leak,
You fixed.
I fix it. If I can find it, I fix it. If not, well, you know what, we get screwed.
No,
with you
because I
there.
can tell you what, some of them are hard to find. Like, I found the one in the deli was underneath the wood floor. The pipe rotted out.
I'll show you. We spoke about rack system, right?
Yeah.
And I did tell you some of these things are up on the roof. And here, imagine I have this rack system up here, and down here is the service area, and I have a unit right in the middle of my service area. And the line that supplies this unit, it has to come down from the roof, through all the ceiling, through the walls. Chances are it's going to come onto the floor and then come up to that, right? If this has a leak someplace, how am I going to find that?
Break the wall down.
And have fun.
No way I'm breaking that wall. You know what I did with what I do in cases like this?
Stop leak.
No, stop leak can't work. I tried it. Stop leak, the leak is too big. I just eliminate the condenser unit here, cut this out, and I bought a unit
Put a
and
new
mounted it right
condenser
next to
unit.
it.
Oh, you just
I put a condenser unit right next to that box inside.
you cut
Because
the lines.
I was
back.
getting so fed up, I tell him, listen, it's either I do it this way or you got some.
Yeah.
Fix it, you know, I'm fed up. But everything is running in the wall or in the ceiling or in the floor.
Because it was built when the building.
Like I said, I had that leak on the deli counter underneath the floor. But we had to cut the floor open,
Yeah.
and it was
So-
the copper actually rotted from them using, I guess, cleaners for 20-something years and spilling salads, vinegars and,
Oh, that salad thing, salad dressing,
yeah.
has a way,
It eats up the
False
aluminum.
eat up the copper because I changed a lot of little blow units for these delis. I have that sort of like
Right.
stuff with salad dressing. What it does that vinaigrette fumes because you have it's citrus base, it's vinegar base, it's
Right.
it's oil base, it's like every single thing
Highly
that's bad for
acidic.
you base.
Yeah.
So it's highly acidic, you know.
Highly acidic.
And
Yeah, it
it
makes
chews
it-
away. It chews away at the aluminum first, then the galvanized, then it begins to attack the copper. So, I find a lot of pinholes in these things, and you gotta end up changing.
I said, when I
them.
found that leak, that copper around that whole area you could put your finger through it. It was so thick.
Yeah. Because this system I'm telling you about, I'll charge it up this morning, this afternoon, call and tell me it's not running, it's not working anymore, it's hot. And I'm like, okay, so, this is the
This is the only way.
only way we can do stuff. No, sometimes you have to do, a man's gotta do what a man's gotta do.
I know.
You know how to take rubber.
Then when I replaced it, I put it inside like vinyl tubing.
So,
Like a sheathing?
Yeah, I put it inside a clear vinyl tubing.
so here's this. On a regular walk-in, you will see some kind of frost formation on a medium temperature box. That's normal. On a freezer, frost is normal, not ice, mind you, right? Excessive, right? Where it's building up to now start bridging across the fins.
Yeah.
That's
That
no
means,
good.
I probably did not go into a defrost, or
You went out.
I have some time, I may be approaching a defrost. Or it could be that my fans are not passing enough air because one of them is probably spinning slower than normal. But because there are 4 in this unit, the air from the other fans are making this one look like it is working because it is spinning. You know? So, right where that one is, no air is going through, so you don't have uniform airflow, so you have ice, frost build up, and it will appear it did not go into defrost. So, sometimes when I see it, what I do is just put it in a manual defrost and let it defrost. And
Why do you do that? By just move the timer, put it
Yeah,
in the
just
car,
move the timer into the
and then
defrost
reset
section
it when you're
and
done?
reset it when you're done. No, you don't have to reset it. Time.
Can't you push the solenoid?
Turn on the light as one here.
Can't you push the solenoid on the back of that time clock and it goes switches right?
No, there's a switch on the thing that you can just turn it off.
No, you can move the clock.
I know you can move the clock until it contacts
Yeah.
switch, but isn't there on the back of that little coil, isn't there a switch on there you can push to pop it?
No, but that's a.
No, that switch is to take it, that's all it is, to take it out of the defrost.
Yeah, okay. There was a switch somewhere, I thought, that we.
No.
There's a switch on the clock that says on and off that you can move manually. On
No,
the
that's-
clock.
That's not gonna put it in defrost.
No,
No, that's a regular 24-hour clock.
right.
The time, the defrost timer is different. You gotta turn the whole thing.
No, I'm saying that'll just turn it off if you turn that switch.
Yeah.
But it won't put it in defrost.
Those were the switches for medium temperature. We had to shut down the box for a few hours and let it clear defrost.
Oh,
It does not energize any heat and elements or anything.
yeah, that's just like.